Hi, I'm Eric Krolke. We're going to work on putting the first problem in Chemical Engineering 455 on into ChemCad. And so I'm going to start today with an introduction. I have a worked problem that's from a textbook, so I know I can compare my ChemCad answers to those answers. One of the key issues you have with any project simulator is to make sure that the simulator is giving you realistic values for the information. So we're going to be able to check that because we've worked the problem by hand already and know what the answers should be approximately. Then we'll be able to make some changes and go from there. Okay, so let's show the computer laptop. And so I'm going to start right from where we are. We're going to get to ChemCad. I have ChemCad as a icon on my laptop. So we're going to click it and get going. I'm going to first show you a worked problem. And this is what's happening with ChemCad as it's setting up. Okay, so now it has said, gee, I've checked your license, so we're ready to go. And I think what we're going to do is we're going to use, we're going to start with what this process is going to look like. So here is the process that I've already drawn. One of the things we'd like to do is we would like to expand this. When we make this on the screen, it's probably going to be small like this, and then when we have all the process equipment in place, we will want to expand the view. It's easy to do that under View. We'll click over here on View, and let's go to Zoom Options. And let's zoom to fit. So this is a much better view. It's got all the elements we need. We needed a pump. We need a furnace. Pump is number 1. Furnace is number 2. Notice that the equipment numbers are in ellipses. The stream numbers are in boxes. So out of furnace 1 comes, in this particular case, it's labeled as saturated vapor. We're going to find out if in fact that's true. This is the expander. Item number 3 is the expander. And then we're going to go into the heat exchanger to drop the temperature down and to condensate everything and then feed it back into the pump. So this has got a natural recycle in it. So one of the things you notice is that the stream 4, which is the recycle connection stream, is in red. Normally in a process simulator, if you have a recycle stream, you have to specify it as a recycle stream. ChemCad, in this particular case, can see, oh gosh, it has to be a recycle stream because the flows are the same, and it knows what to do. It's got a special procedure for cutting things and doing the analysis. Okay, so what we have done is taken a textbook problem which was stated in terms of enthalpies and entropies and temperatures, and we've changed it into simulator language which would be temperature, pressure, composition, flow rate. The good news is we only have one component in the working fluid. It's water. So that makes the material balance very easy. So the temperatures and pressures that we put into the simulation here are all from the work we did in examining the problem initially. So that's all the handwork that we did. So let's go back and let's take a look at, we will set up the problem from the start. And typically what we're going to do is we're going to look at the format and specify the engineering units first. Then we're going to specify the thermal physical systems that we're going to use. We're going to put together elements of the process. We've got 4 elements: pump, a furnace, expander or turbine, and a heat exchanger. We're going to find those unit ops over here, put them onto the flow sheet, connect everything, start to specify streams. So that's going to be our working process. And here we go. So I'm going to close this file out. We'll come back and compare things later, see if we did well. I'm going to close it. And we're going to start from ground zero. So, File. I'm going to start a new file. And first thing I'm going to do is save it. If I can. Whoops. File, save. And I'm going to call this problem 1 example. Problem 1, Rankine example. That'll differentiate. How about that? And notice it appears down here. Now the first thing I need to do is to choose my engineering units. So let's take a look at what the choices are. I'm going to magnify this just a touch and then try to slide things over. There we go. So here's the engineering unit selection. We typically can choose English or Common SI. Let's see, let's move up here a little bit. Common SI, Formal SI, Metric. Let's take a look at Common SI. Well, let's see. It depends on how we have the data. I happen to have the data in terms of degrees centigrade. So why don't we use that? I don't want to use bar. Let's use kPa. I haven't had the data as kPa. There we go. And the flow rate, I have kilograms per second. Let's see. And so liquid volume, I want to talk about kilograms. Or actually, let's see if I've got this over here. Yeah, I should be okay. Well, we'll come back and adjust them if we have to. Let's choose this one as we've modified it. And let's go back to our process. We don't have anything there yet. Let's choose our components. Well, here is the component tool. There's a bunch of names. If you know the CAS number or the formula, you can search for your item. We only have one item. It's going to be water. We can put in water, or we could do H2O. And there's water. So if I click on that, highlight it, and then enter it into the selected components, it's entered. So for this problem, we're done for component selection. The next thing that comes up automatically is the thermodynamics wizard. Let's increase this a little bit. So we need to put in the minimum temperature and pressure. Let's put in as a maximum. What it's going to do is take this information and figure out what we're doing. Let's put in 600 C as the maximum. And the minimum pressure, I'm pretty sure is going to be something like 10 kPa. And I think we're going to be working with 8,600 kPa. And we're not going to ignore any components. We're going to include water as our own component. So let's say yes. So it's already selected some thermodynamic packages. It's selected a partition coefficient thing, which is not important. It's included SRK for the enthalpy. Let's say yes. And then, so it's going to do, if we need, as you remember, K values are going to be if we need partitions between different phases. This is sort of irrelevant for this particular problem. We're not going to have any, in terms of vapor association, no association in the vapor phase. We're not going to use correlations. We don't have any special package, although we could. We're going to say there was no hydrocarbons in the system, so we could ignore this one. And we're going to reflash the input streams for local H models. So this screen is just fine. The next screen we might look at is enthalpy models. So let's take a look at choices. SRK is probably the best in this particular case. And we're going to use Dipper data for the heat capacity and the steam table. And this is where the steam table is coming from. We could also do a quick fix, but this steam table seems to be pretty good. The transport properties, we're probably not going to use any of these, but this will correct for liquid viscosity and so forth. So those are all okay. Let's go back here. Let's get smaller, and let's close out. Okay. The other thing we could have done is we go into the wizard, we could check the thermodynamic settings. So if we do that, this puts us right back to these same boxes that we just looked at, right? So we could either do it by the wizard, or we could go through and do this by hand. So now we have set up the format, engineering units. We've set up our one component, water. We've specified how we're going to do this. And we're going to start now putting equipment onto the spreadsheet. And ChemCad is going to label these in the order that you put them in. So I'm going to put them in sort of a random order. And we'll have to do things like put a new label on those or change the label. I'm going to start out here with the heat transfer heat exchanger, because we know we need one. And if I go over here and right-click on the exchanger, I'll see a number of different choices. The first choice is very simple. It's sort of an automatic exchanger with one or two input streams. I think what we want is a little bit more complicated exchanger. We'll start with this guy, number 2, and we're going to move him to the flow sheet. Okay, so we've got an exchanger. There's a compressor. We want the expander. There's the expander. Let's see, we have different kinds of expanders. We have several types. I'll take expander number 1. So here's expander number 1. And notice these are small. We're going to fix that in a minute. Now, we need a furnace. We could actually model the furnace as a reactor, a chemical reactor, to generate, to burn the fuel, and then to heat up the liquid. But what I'm going to do is I'm going to use a fired heater, and we'll explain some of the reasons for that. But let's put a fire heater in, and then the last thing we need is the pump. So let's go down here and find the pump. Here's a pump. We'll right-click on that. We'll take pump number 1. Good. Okay, so now these are all poorly scaled. Let's then zoom in to see these. I'm going to move these around a little bit. Okay, so I'm going to start to connect things up. In ChemCad, we have a connector tool, and we always, you'll see on one of these pieces of equipment, like the pump, we have a blue dot and a red dot. The blue dot shows the input to the pump. The red dot shows the output. So I'm going to click on the red dot. If I click intermediate spots, it'll give me a line, and I'm going to click it right to here. So I've now put in stream number 1, connecting the pump to the fired heater. So this is that's going to be the flow. Now I'm going to connect the fire heater to the turbine, or to the expander. So I'm going to click on this red dot, go over here, click, and now I'm connected. You see, once I'm connected, I get a little box around where I am. Okay, so now what I want to do is I want to connect the red dot on the turbine to a blue dot on the heat exchanger. You notice that this is sort of going to be inconvenient because I've got a recycle stream. So let's do this. Let's right-click on the unit op. And what I'd like to do is I would like to flip on the horizontal axis. And I want to flip this around. So I just did that. So now I'm going to connect up the red exit from the turbine. There we go. So now I'm connected. Now I'm going to take the heat exchanger exit, which is the condensed fluid, and connect it to the pump. Oops, I missed it. Good. So now we've got stream 4. Okay, now just to clean this up a little bit, we would like to, we've got this as a nice process. I'm going to, again, zoom to fit. There we go. Make it a little bit bigger. And let's go ahead and swap these unit numbers out because I gave these different unit numbers when I was doing the Chalk Talk. So if I right-click on the icon, I can see Edit Unit Op ID. I would actually like to have this pump be number 1. I'm going to say OK. It's going to tell me it's already in use. And that's fine. I don't want the heat exchanger to be number 1. So I'm going to hit OK to switch the unit IDs. There we go. This one, I would like to have, this is the furnace. I would like to then do the same thing. I would like to make this number 2. I'd like to swap those. Cool. Now I've got everything going the way I want. I've got this thing all set up. You notice now that I've got a recycle stream which is red. That's stream number 4. So what I'm going to do now is I'm going to start specifying stream conditions and the conditions of each piece of equipment. So let's start with stream 4. Stream 4 is the entrance to the pump. It's going to be low pressure. It's going to have all the flow of the liquid system. So I'm going to double click on stream 4. And stream 4 is going to be condensate. I'll label it that. I know what its temperature is going to be. I'm pretty sure it's going to be 318 or extremely. Excuse me. Let's put it in degrees C. Actually, what I'm going to do is, I happen to have the data in front of me. I'm going to go back and change the format here. Engineering units. I'm going to put this in degree K because I happen to have that. So let's do that. Now let's go back to stream 4. Let's zoom to fit because I changed things. Okay, now I can get back to stream 4. All right. So the temperature of the condensate is going to be 318. The pressure is going to be 10 kPa, so it's 0.01 atmosphere. Vapor fraction, I'm going to leave it alone. I'm going to specify the water flow rate. I don't like this unit, so I'm going to make it in kg per second if I can. And I see I need to go back to the engineering units and see if I can find it this time. Okay. Well, apparently I can't, so I'm going to put this into kg per hour, I guess. And I don't want kilomoles, I want kilograms. Okay, so I actually have 60 kilograms per second times 3,600 seconds in the hour. And so I'm going to have a total flow of 216,000 kilograms per hour. I'm going to flash it to make sure I get an enthalpy. Right. Okay, didn't like it. Oops, I've got to put this back in. This is going to actually be 45. Pressure is going to be, oops, I'm going to have to go back and reset all this stuff. Okay, now that looks like it's better. Now let's flash it. That's good, we got an enthalpy. Okay, now let's go to the pump. What you usually want to do is you want to specify a stream in front of a piece of equipment and then specify what the pump is, what that equipment's going to be like. So let's expand this a little bit so we can see what's happening. Okay. So we want the pump on. We want to specify the outlet pressure. The outlet pressure that we want from the pump is 8,600 kPa. So this is fine. There are other choices. If we know the pump curve, we could do that too. 8,600. Efficiency. Let's put it in as 1 per 100. So efficiency goes from 1 to 100. If we need help on any of this, click the help button. And then here's the details of what the pump does, how you specify here. We notice that the efficiency is, the default efficiency is 1. They have a characteristic flow rate. And if you want to put in pump curves, here's how you do it. So let's go up here. And let's get out of this help screen. Good. So let's go up here and see if there's anything else we need to do. We have a fixed flow rate, and I don't think we need to worry about what this is. Yeah. So we basically, anything in green that we have to specify, we're done with the pump. Okay. So let's go back to full screen. Now, we have now specified the pump. Let's run this piece of equipment, make sure it works. So we right-click on it, run this unit up, and it says, okay. There's no errors, no warnings. We started and finished the run. This is now computed. You notice we have numbers in here now. Okay, we have the calculated power. And then, so we know what size pump to buy. It's probably not in a convenient set of units, but we can figure that out later. But all the calculations are done. We haven't done cost estimation. Let's go ahead and run the costing report after calculating the unit. Okay, and so here it gives you a typical item. So let's go ahead and say OK. Then let's go back over here. Let's right-click on this thing, run it. And we'll go down here and see, did it run? Yes, it did. Okay. Now let's check the costing. Let's do tools and do costing. We're going to select equipment. Select equipment number 1. And we've got a pump cost. Well, the pump is going to be installed. The purchase price is about $16,000. And I'll have more information. The installer price is about $146,000. So this is a major pump. This is pretty big. Well, the flow is pretty big too. Okay, so we're now seeing something about the nature of our problem. Let's click out of this and let's keep on going and get this problem solved. We're not going to save that one. Okay, so let's go to the fired heater. Fire heater, we're going to specify this. I'm going to basically have to specify the pressure or the temperature coming out. Temperature coming out I want is 773 Kelvin. I don't have to specify anything else. What I do want to do is I want to specify that I want to run the costing report. We've just seen that the pump is going to be humongous. Let's see what the fire heater is going to look like for this process. Okay. So let's go here and let's run the unit up. And it looks like it's done. Whoa, gee. That's pretty interesting. When I hover over the piece of equipment, it gives us some key information. It gives us temperature out. It made the temperature out. It tells me how much heat needs to be absorbed to get that temperature. And it tells me the fuel usage. This is standard cubic feet of methane. And it says that this is going to be a $14 million furnace. So that's pretty impressive. Let's check to make sure that stream 2 is calculated properly. If I can get there. Let's back off. There it is. Okay, so I hit 773. I hit the right pressure. That's all good. Now let's go to the expander. Okay, let's make this bigger so we can work on it. This is the expander of the turbine. We're going to specify the output pressure and the efficiency. Right now we're going to make everything ideal, so we're going to put an efficiency of 1. The output pressure, we know from our calculations that it is 10 kPa. And we're going to have it be adiabatic. There's other choices we can make. If we know the work and efficiency, blah, 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 we can put that in. Adiabatic, polytropic, we'll just make it adiabatic for now. And then anything else we need to do, nothing there. It's going to calculate everything for us. And again, we want to run the costing, okay? And then we're going to make it a centrifugal compressor, or we can go to help to look at these things. I'll let you do that when you're setting things up. Let's go ahead and run this unit up until we get a run. Yes, we did. Okay. So let's go back up to the top, and we're going to fix this by zooming to fit. There we go. There we go. Okay, so stream 3 then should be correct. Looks like it is. Notice we got some vapor fraction in there. So the calculations we did by hand, we started to get some condensation. We'll have to address that later in the process. Let's do the final thing. Let's get the heat exchanger specified. Okay, let's take a look at what we can do here. For designing, you can do design or rating. Rating means that you put in details of the piece of equipment and you put in the actual operation, and it will tell you what its heat transfer coefficient is. In this particular case, we're going to put in the temperature of the stream, or the vapor fraction of the stream, and get things solved that way. So I think what we'd like to do is let's put in the vapor fraction of the stream, and let's put it in just as a little touch of water. The utility temperature in, this is for the rating case. For the design case, we don't have to enter anything. And we want it to do a cost. So, okay, so now let's run this unit. It looks like we got something. Let's make things smaller. Let's see what stream 4 looks like. Okay. Stream form looks right. Let's do this. Let's run the whole thing. To run the whole thing, I can either click on this thing and say run steady state, or there's a nice little blue triangle here which says run all. I'll do that. And notice it tells me that the recycle convergence has been accomplished, so I know that everything now is completely set. Let's check stream 4 and see what it actually says. Temperature is not quite 318, it's 318.9. That's great. What about this temperature? This is, okay, 318, okay. Good. So now I should be able to get all the details here. Let's take a look at the fired heater. You want to take a look at the cost. There's the installed cost of 14 million. Okay, let's take a look at the horsepower. Let me expand this a little bit so we can see that. Okay, so here's the actual power generated in the turbine. 275,000, a quarter of a million millijoules per hour. That's great. There's the theoretical power. The efficiency we put in is 1. And so that should be the same. That's good. We'll click OK. Whoops, went the wrong way. Here we go. Let's get the price. Let's see. I'm just going to see if I can't hover over it. Get it? Maybe not right now. There we go. So there's the total installed cost, which is almost $22 million for the expander. Okay, installed. All right, let's take a look at the heat exchanger installed. We didn't get a price thing. Let's worry about this. Let's do tools, costing, edit costs. Okay. Select equipment. I'm going to select all of them. Okay, here's a cost estimate. Let's see what we got. Got a cost estimate for the heater, fired heater, cost estimate for the expander, and then basically the exchanger is well out of whack. So we'll come back and fix that, and I'll show you how to fix that in class. Or we'll figure out how to fix it by looking at the other sheet, I think. Calculated heat duty is there. And we probably need to put in the overall U to do this. Okay, so we now have something that's close to running. We have to fix the exchanger. Let's close this out. Let's save it. And then let's close the file. And let's open the Rankine cycle 1B. And let's check to see what this exchanger is. Okay. Okay, let's take a look at the utility rating here. I think we got go to Tools quickly and get costing. See if I got, yeah, let's do that. Yeah, it didn't like this either, so I probably need to put in a different kind of exchanger so that I specify the heat transfer coefficient for the exchanger, which we haven't done. I think we'll probably do that as part of an exercise in class because that'll take a little bit of time. And with that, I think we're done with this particular problem. Let me see if I can close this out. There we go. So you can see how to set things up. It looks like it's calculating the elements properly. We need to do a little work on the costing for the heat exchanger. Maybe choose one where I can specify the heat transfer coefficient so I can get a size. I didn't do that, so it didn't give me a cost estimation. But this simulation looks like it's going to work. We can now then modify this to put in a different portion of the heater. We would have we'll have a fire heater plus an expander or a turbine, and then probably another fire heater plus an expander or a turbine to recover extra heat from this device. And that will give us a much better simulation for the Rankine cycle with reheat. So with that, I think we've finished the first problem, and we're ready to go to the simulator. We'll try to do this in class so that you can see exactly how to do this, but the only problem we had this morning was to look at what is the heat exchanger cost. But now we've got heat exchanger costs, we have sizing, we have enough to do economics and see what this process is going to cost us, and now we're ready to get into serious design. Thank you.